All right, additional topic number 3 is on Newton's method. So just like we talked about before, this is a BC topic, something that's in first year calc all the time now, so we're going to talk about it. All right, so pre-calculus, you learned how to find the zeros of polynomial. Do you guys remember my favorite theorem ever? What it's called? The rational roots theorem, the P over Q theorem. Do you guys remember that?
That's your favorite?
It's my favorite theorem in the whole wide world.
Your favorite
I don't know. I like it. All right, anyway, so this allows you to factor huge polynomials. You can find the zeros. You can use the quadratic formula. You can find complex zeros, all kinds of things. But how do you find the zeros of something like tangent of x minus x by hand? Or 48x times something to the 60th? You know, how do you do that? So you can use calculus to help us approximate solutions. So here's a sketch of what we're going to do. So let's say we have some kind of curve. Oh, it would help if I've calibrated this. Hang on. All right, so we have, it's going to come up and down, up and down. It's going to cross the x-axis a couple times. All right, we want to know what the zeros are. Do you guys remember zeros are the x-intercepts? So we want to know how to find those.
So x equals 0.
Yeah, but what if it's a really hard function and we don't know how to factor it? So we can't always just set x equal to 0. Okay, so let's say 1 is right here. Guys, so let's say 1's there. It's pretty close to a 0. All right, what we're going to do is we're going to go up to the curve and we're going to draw a point. And all of us know how to find the tangent line to a curve, so we're going to draw that tangent line in. Okay, so here's my tangent line. Okay, this is going to be called my x0. It's my first guess. Okay, where I cross on the x-axis is called x1. Okay, that's my next guess. Okay, so then what I do is I say, okay, well, x1, now I'm going to find where it matches up on the curve. So I'll call this my first tangent line. So first line. Now I create another tangent line. And that one gets even closer. Doesn't that look even better? This is going to be x2. It's hard to draw, isn't it?
And then you go up and you make another tangent line?
Yeah, and then it keeps getting closer and closer until it approximates that 0. Pretty cool. So it does it pretty quickly. Now, what if I had my first initial guess? I wanted to try to find this 0 here. And I tried right there. Is that going to help me? No, because it's not going to cross the x-axis. So sometimes your initial guess will be bad. So that's the bad thing about this. Sometimes you're really bad at first guesses. So you always have to be kind of close in order for this to work. Okay, so this is, why do we learn this? I mean, you guys all know how to find the zeros with your calculator, right? What do? Plug in the function, hit find 0, left bound, right bound, you have it, right? So why do we do this? What's the point? If you don't have a calculator, if you're in the non-calculator portion, and then your calculator, do you know what it's using to find that 0?
It's probably Newton's method.
Newton's method!
Oh, yeah.
It's amazing. So it's really important that we know how to do this because sometimes we have to input things into our calculator. We have to program the calculator to do these things for us. So those of you that are future computer programmers out there, this will be useful. All right. Okay, so the key to this method is called Newton's method. And the key is to have a good initial guess. So we call our initial guess x0, like I said. The next one's x1, the next one's x2, x3. I call these the xi's. Okay, the equation for the slope of the tangent line at x0, we know how to find the slope, right? y2 minus y1 over x2 minus x1. It's set up like that. So we're starting here. Okay, if I multiply my x minus x0 over, you end up getting, this is f of x, right? All right, f of x, so you guys still have that? So f of x equals, so it's really, let me write out one more step. So f of x minus f of x0 equals f prime of x0 times x minus x0. So I just multiplied my denominator over. All right, I'm going to call my f of x y. So it's the y value for any x value on that tangent line. Now think about what one's going to be useful. So our tangent line, we're talking about any x value along that, any point along that curve. The one that's going to be useful for us is the x-intercept. If you have an x-intercept, what's the y value?
0.
0. So that's what we're going to do. We're going to let y equal 0, and then we're going to solve. So we have 0 equals f of x0 plus f prime of x0 times x minus x0. So to get from my step to the step I had written, I just added the f of x0 over. All right, and I want to solve for x, because I'm trying to approximate the next x term, which we said the x term we're worried about is x1, right? So this will give us x1. All right, so if I'm solving for my x term, I'm going to subtract my f of x0 over. I get f prime of x0 times x minus x0. Now what?
Divide.
Yep, divide. So you have negative f of x0 divided by f prime of x0, and that's going to equal x minus x0. So the last step is just add the x of 0 over. This gives us x1. So this is x1. So that x value we found was the x-intercept.
And this is not on our exam.
No, this formula is not bad though. It's really not. So basically, if you're finding any xi term, so if I want to find x3, I'm going to use the term before it, x2. Okay? So, and what you do is you take that term before it, you subtract out the y value divided by the y prime value for that x0 term, or x2 that I was talking about. Make sense? Okay. So it's just an easy formula. It's not bad. So part A says use Newton's method with the equation x cubed plus 3x squared minus 1 equals 0, and the initial guess x sub 0 equals 1 to compute x1 and x2 by hand. Okay, so this is what they had to do back in the old school days when they didn't have calculators. Yeah, so we have to actually find this by hand. All right, so first of all, what's my f of x?
X cubed plus 3x squared minus 1.
Yeah, but we didn't really define f of x, so make sure that you know, if you had this on an AP question, we always talk about how you need to define functions, right? So define the function. And I want to find x1. So in order to find x1, I'm going to have to do x0 plus f of x0 divided by f prime of x0. Okay, that's my formula. So I need to find those different things. I need to find f of x0 and f prime of x0.
Isn't it minus?
Oh, yep, sorry. It is minus. All right, so okay, so we have f of x, we need f prime. So f prime of x is 3x squared plus 6x. So x1 is going to be x0 is 1 minus, what's f of 1?
3.
3, right? You plug in 1 everywhere. What's f prime of 1? 9. So I have 1 minus 1/3. I get 2/3. That's x1. We found that. Easy enough. Now it's time for x2. It's a little bit harder. All right, x2.
I don't understand what we are doing.
You don't understand where we are? Okay, where did I lose you?
At the lens.
Okay. Guys, so that's saying find f of x0 was 1. So f of 1 is just plugging in 1 into our f function. So 1 plus 3 minus 1 is 3. F prime of 1 is plugging in 1 into our f prime function. So 3 times 1 squared plus 6 times 1. So 3 plus 6 is 9. So then it's just our formula. So 1 minus f of 1 was 3 over 9. So we have.
I get that, but
I know, but that's not our 0. Like, f of 1 gave us 3. It's not 0, right? We want to find the thing that when we plug it in, we get 0 out. In other words, we're finding the x-intercept. So 1 isn't the x-intercept, but it's close. It gave us a small value. It gave us 3. All right, so now we have x2. All right, so x2 is going to be x1 minus f of x1 all over f prime of x1. So x1, we just found it. It's 2/3. So I have 2/3 minus f of 2/3. Yeah, aren't you glad that you have calculators today?
Yeah.
All right, divided by f prime of x1. So we've got
So 8 plus 1.
You're going for it? We'll go for it.
Yeah.
2 minus 1 all over. Let's see, we get 4/9 times 3, so 4/3, plus 12/3, so 4. That's a 4. Oh, man. So plus 4. Still not calibrated right. Okay. 4/3 plus 4 is on the bottom, yeah. What'd you get? 79 over 144 is your total answer? All right. 79 over 144. Nice. Good fraction skills.
Did he just do that in his head?
No, calculator. All right, so you get 79 over 144. So think about how time-consuming x3 would be. Do you guys understand? x3 would be pretty annoying.
Yeah.
So it would take a long time.
All right, so back in the day when I was in college, I took a class called numerical analysis. So it was all like numbered things, plugging numbers into the calculator, getting all these answers out. And we did Newton's method, and we usually do Newton's method to like the 6th iteration most of the time. But I, being an overachieving student, like, you know, I got one and I came up with the wrong initial guess, and I did 18 iterations before it finally like came out to be a nice number. And my friends were like, "You're stupid. You should use this value. It would have been much faster." All right, so it could be really time-consuming using Newton's method without a calculator. Like we didn't really like set it up in our calculator. Really, we used the calculator for like 2/3 and things, but we didn't really use it the way that I'm going to show you. So I'll show you an easy way. All right, so we found x1 and we found x2 by hand. Now part B says use a calculator to find the root to at least 4 decimal places of accuracy. Okay, so what I mean is we're going to use the calculator in the way that I'm going to tell you, but I'm guessing that you guys want to actually graph it and find the 0 the way that you know how to do. So graphing. So if you graph our function, we're going to find the 0. Okay, and we want the one that's close to 1. So if you guys graph it, you guys have some kind of cubic function. So there's 3 zeros. Oops. So it looks something like that. And here's where 1 is. So we want this 0 that's right there. So get on the left side of it, hit enter, get on the right side of it, hit enter, and guess. Have you guys ever like tried to find a certain 0 and then it's so close to another 0 you get the other answer?
Yes.
Because of Newton's method, right? It's getting the wrong one. You weren't close enough with your left bound, right bound type thing.
Is that what your calculator does?
Yeah, your calculator messes it up. All right, so we get 0.5321. That's what we're shooting for. 0.5321. All right, so I'm going to show you how you do this with your calculator. It's kind of hard because I don't have one of those fancy things so you can see it on the computer, but here's what I'm going to put in for y1 and all of these. So y1. I'm going to put my function, f of x. So I'm going to put x cubed plus 3x squared minus 1. y2, I want to put the derivative of my function. So I want to put f prime. Now you can do that a couple different ways. You can actually find f prime, right?
Or you do inderiv.
Inderiv, right. Inderiv's going to be nice because you're going to have lots of different functions on your homework, and you can always just change y1, but you don't have to even compute y2 because it's finding that numerical derivative for you for every x value on your graph. Okay, so inderiv y1 x. Do you guys remember?
X.
X, right? Because if we did the normal inderiv for just one number,
0 to 1.
if I wanted to find the derivative at 5, you would do x comma 5. But we want it to plot every single x value, so do x comma x. All right, and then y3. Y3 is going to be our formula. So y3 started out with some kind of x value, right? So we're going to put x minus, it started with f of x on top and f prime of x on the bottom. So I'm going to do y1 over y2. Remember how to do those? Bars, y bars. All right, do you guys have it all in?
Yeah.
Speedy. All right. So only highlight y3. Otherwise, you have way too much information on your table. All right, and then hit table. Be careful, don't hit graph. It takes forever to graph. Did you guys just do that? So hit table. All right. So now here's your table. So you're only looking at y3. What's the first x value we wanted to try? 1. Remember it told us that we wanted to try x equals 1 for our first guess. So that's my x0. Okay, so I'm going to plug 1 into the table for x. What do you guys get?
0.666666666.
Yep, now you can arrow over to see exactly what that number is, like along the bottom. It gives you more decimal points. Like the first class, they kept saying, I can only see 5 places. And I said, well, just arrow over to that number and you can see more. Now my calculator is pretty old. So it doesn't, like yours said 0.66666 and the very end 7 probably, like some of you guys have said that. Mine says 0.6666667037004.
Yeah.
Okay, so this is, the older calculators don't have as many like bits or bytes or whatever it is, as much memory as the newer calculators. So some people are getting, did you get that? Yep, so William has all 6s and a 7 at the end. So that way he can definitely tell it's 2/3. Mine looks like it's been rounded somewhere.
Is your rounding error?
There is a rounding error. Yep, the calculator couldn't handle all those different digits. Okay, so we're gonna go to like 7 digits. So 666, 6667. Yeah, we'll do that. Okay, that is now x1. Make sense? That's gonna be what we plug in for the next thing. You can be lazy and just do an arrow over there. Okay, it's really sad that you can't store values from your table. So you actually have to type it in. 1, 2, 3, 4, 5, 6, 7. Okay, now do you guys get like 0.5486111? Did you guys get that? That is now going to be x2. So now that's going to go here. See how it works? Your next one is 0.53239. Oh, wait. Am I looking in the wrong spot? That's what I do. Okay. Oh, I just still have the same number from last class. Okay, so and then it's like 0, 2 or 0, 1, 6, 5. Okay, so we'll put that in the next one. So 0.53239. So you get 0.5320088. So, okay, so if we just want to 4 places, we stop when we have the first 4 places the same. So we're really close. Do you guys see how we have 0.5323? But now I had 0.5321, basically. So let's do it one more time. I think that was 88, right? I should do 88. So you get 0.5320088 again.
So theoretically, the more you do it, the closer you get.
Yeah. So your 4 decimal places of accuracy would be 0.5321, which luckily you know what you're shooting for, right? Because you can cheat. Okay, makes sense? So just iterations. Keep doing things over and over. All right, so use Newton's method to approximate cube root of 7. Our first class was struggling with this question. I think you guys can do it. So what equation do you need in order to get this as a 0?
Y equals.
So f of x equals.
Okay.
Nikki's got the first part. Anybody want to carry it home here?
7 to 1/3.
No. Nope. Okay, think about it. So we want cube root of x or cube root of 7 to equal our x value.
Oh.
So that means 7 equals x cubed, which means x cubed minus 7 is going to equal 0. We want to find the zeros of some function. So we're solving x cubed minus 7. All right, so we need to find f prime. Well, actually, we don't need to find f prime because we can just use the derivative on our calculator. So we're going to go to y1, and we're going to clear out that y1. But now we're going to do x cubed minus 7. Make sure you de-highlight it, too, for your table. And we do the table. What would be a good initial guess for this one?
7.
5. So 5 cubed minus 7 is close to 0?
No.
No.
3.
3 cubed minus 7 is 20.
2.438.
Why 2.4 something? What about 2?
2
is closer, right? 2 cubed is 8.
Because it's a pain.
You're thinking 2 cubed is 6. 2 cubed is 8.
What?
2 cubed is 8.
Okay.
What is that?
Alex just wants to get fancy with 2.44 or something. All right, we're going to use 2.
1.
I think we should do 1.912.
Yeah. Is that really close to the answer? All right, so we're going to do 2. So put 2 in. So you get 1.91666667. Put that in for the next one. Okay, I left out one of my 6s.
Wait, so how many would you say to normally do?
Oh, enough. The more you use, the better it's going to be. You know, like the less you have to do. So that's approximations.
Okay.
So 1.912938. I usually stop where there's no, like, I mean, it was 8.4, so I didn't have to round up or anything. All right, so next one. 1.912938. 1.912931. Okay, we want to get, let's say we want to get 4 decimal places in common. Are we there? Oh, yeah, we are. Good. I just randomly said that, so 1.9129. That's what your homework says, 4 decimal places. Okay, making sense?
Yeah.
All right.